and gentlemen, so today we're going to now take a look at using the applications of the Pythagorean theorem. So that means some word problems. It also means that now maybe we might not be looking for C, the hypotenuse. All right, but before we even get into that, let's remember what our formula is, and hopefully all of you are in your head saying right now, a squared plus b squared equals c squared, right? C is always the hypotenuse. It's the longest side. It's across from the right angle. So here we have given a right triangle with a hypotenuse with length 13. So they're telling me this is the hypotenuse. I'm going to label it C. And a leg with length 5 units. So it doesn't really matter if you call this one A or B. I'm going to call it A. We want to know the other length. So this is what we're looking for. B we don't know. So now when I put it in, it's going to be turned into an equation that we're going to need to know how to solve. You can do this. So we start with our formula, a squared plus b squared equals c squared. I'm going to fill in my numbers. A is 5. B we don't know, so it's going to stay as a b. C is 13. And now just like we did yesterday, I'm going to go through, I'm going to do that math. 5 squared is 25. 13 squared is 169. Now, I did those in my head. You, of course, can use your calculators. But now what I need to do is, like when I'm solving any equation, I have to get my variable by itself. So I have to subtract 25 from both sides. Right? So just like we solved equations that we've been doing now for 2 years. So b squared, if I do 169 minus 25, I get 144. And now I have to say, is there a number that I can multiply by itself that gives me 144? And the answer is yes, it's 12. So I know to get to b squared, I had to do b times b, and to get the 144, it would be 12. Remember, if you can't take that, if it's not a perfect square, then we're allowed to just leave it for right now. So here's another, taking that same triangle, but now putting it into more of a real world situation. So suppose you have a ladder of length 13 feet. Suppose that to make it sturdy enough to climb, you must place the ladder exactly 5 feet from the wall of a building. You need to post a banner on the building 10 feet high above the ground. Is the ladder long enough for you to reach it? So we need to put, we're really looking for this side right here. Well, here's my right angle, so across from the right angle, look at it. I'm going to highlight this. I just made, when you set up a ladder like that, you have made a right triangle, right? The ladder is representing the hypotenuse. The height of the wall is a leg, and how far it is from the building is a leg. So here's your A, and we're looking for B. So exact same situation that we had up there, but now it's in a word problem format. So a squared plus b squared equals c squared. Right? I'm just going to go through and kind of get down to the end, because if you look, it is literally the exact same numbers. 13 and 5, 13 and 5, we're looking for B. So we already know B is 12 feet, right? And I'm going to write C work above. Now, if this was a problem on your test, you guys know you can't get away with that. But I'm trying to save some time so you don't have to watch a video of me doing the same exact work. But the question says, is the ladder long enough for you to reach the location you need? And it needs to be 10 feet. So am I able to get far enough up? Yes, the ladder is long enough. Because the ladder will actually go 12 feet, I only need it to go 10. Okay, let's take a look at some other problems here. So now we can also use this to find the distance of a line that's plotted on a coordinate plane that might not be straight up and down, right? Here we're going from A to B. Well, we've already looked at being able to find the slope or the constant rate of change of that line. We're going to now use the same idea to help us figure out not just what the rate of change is, but how long is that line? Because this line, to get there, right, I had to go up and over to get there. Well, look at what I've made. I've made a right triangle. And what did I go up? I went up 1, 2, 3, so that side is 3. I went over 1, 2, 3, 4, 5, 6, and I don't know how long that line is. So when I make my right triangle, I can now use my Pythagorean theorem. So this is your A, this is your B, this is C, because it's across from that right angle we made. So this is like a problem we did yesterday, but instead it's on a graph. So we have 3 squared plus 6 squared. We want to know how much that is. So 3 squared is 9, 6 squared is 36, right? I already have C by itself, so now I'm just going to add those two numbers together, which is 45, right? And I'm going to stop there. Eventually we're going to learn what to do with it, but for right now, because 45 is not a perfect square, I have to stop. All right, here's another example of a word problem. Given a rectangle with side lengths of 8 and 2 is shown, what is the length of the diagonal? Well, again, right here, I have a right triangle. Here's your right angle. I'm looking for the C. So this right triangle is found in lots and lots of different places, and it's used quite often in things like architecture and engineering. Okay, so this is my C, this one's A, this one's B. You could reverse those because the commutative property says I can. And filling in my numbers, so we have 8 squared plus 2 squared equals C squared. 8 squared is 64, 2 squared is 4, 64 plus 4 is 68. That is not a perfect square, so we're going to stop right there. Okay, I want you guys to try these, so I'm going to ask you to pause the video, and then you can come back and check your work and see how you did. All right, let's see how you did here. So in number 5, you were looking, I chose to look for B, but so you had to fill in 25 for C and 15 for A, and 400 is a perfect square because 20 times 20 is 400, so B ends up being 400. In number 6, okay, the ladder is your 15 feet, that's your C. I made the height of the wall the B, and I was looking for A. So over here, when I filled them in, and then I had to get A squared by itself, so you'll see I subtracted 81 from both sides. And 144 is a perfect square, and it's 12. Notice because it gave me a label, I had to make sure I included a label in my answer. For number 7, I had to go through and draw in my triangle, right? Just like as if I was finding slope up and over. So we went up 4, we went over 3. So that's going to give me 16 plus 9, because I'm looking for the C. It's across from the right angle, which gave me 5 because 25 is a perfect square. Okay, so down here under lesson summary, the Pythagorean theorem can be used to find the unknown length of a leg of a right triangle. An application allows you to calculate the length of a diagonal of a rectangle, the distance between 2 points on a coordinate plane, and the height of a ladder that can reach as it leans against the wall. Okay, so those, again, we'll see more and more types of applications. Any questions, as always, bring them to class and have a good night.